One other thing you can do with PERT, because we have three estimates of time for each one of the activities and we calculated the expected time and the variance, we then can calculate what the probability is finishing the project. Now, based on what we've done so far, because we did do the expected time, we can assure you that think about this way. If you have a normal distribution and we are saying we believe that we can get the project done in 15 weeks, that's basically the halfway mark. We have a 50-50 probability of finishing it. And so we've hit that majority mark. But there is still a probability that it will take longer. All we can say is 50-50. But we can calculate then if somebody were to say, well, what would be the probability that you have it done in 16 weeks if we had an additional week, or 17 weeks if we had 2 additional weeks? Or we could even calculate the probability of getting it done early. Let's say they wanted to know the probability of having it done in 14 weeks instead of 15 weeks. You know that's going to be less than 50% because of your normal distribution. So given that we calculated expected time and used that for our forward and backwards pass, and we determine the length of this project is 15, we can say that there is a 50-50, or that we are only confident to that degree. So if we wanted to be more confident, we would want to add time on. Now, how do we figure that out in regards to other facts and figures? There's a couple different ways to look at this. One is you want to look at the variance for those activities on the critical path. It doesn't matter if the activity isn't on the critical path. It can vary, and we don't care about that because it already has slack. Whereas we're very concerned with those activities on the critical path that have a lot of variance. And so I'm going to add up the variance for those activities on the critical path. So we said it is A plus C plus E plus G plus H. Yes, we have calculated variances for other activities, but they weren't on the critical path, and so they don't affect the overall length of the project. But these activities on the critical path do affect the length of the project, so we want to know what the sum total. Now, remember, this variance is a squared figure. So to make sense of it, we actually want to convert it back into the units we are using, which is weeks. So we can take out the square by using a square root. In Excel, we use a function called sqrt, which is for square root. And then we plug in the number that we want to have the square root of, and that would give us then, we can say that our project, a standard deviation, is 1.76 weeks is one standard deviation that we can, if we're looking at that. Now, if you wanted to be more assured, think back to what you know about normal distributions in regards to 1 standard deviation plus or minus, or 2 standard deviations, or 3 standard deviations. If we wanted to make sure that we were 99% sure that we would get it done, remember that 3 standard deviations captures 99% of the normal distribution. So we would just simply take 3 times 1.76 weeks, and that would tell us then what the project end where we would be 99% sure. But in the book, they want you to figure out what the probability is that you'll be done in 16 weeks. And so the way we do that is we take the 16 minus our expected completion date. If they were to give you a lower amount, let's say they wanted to know if it was done, what the probability is in 14 weeks, you would still put that in as the first number, and that would give you a negative number so that we can see what the probability is. And then you divide by this standard deviation we have. And this creates what we call a z-score. So they're giving you 1 week more compared to what we consider to be a standard deviation. So 1 divided by 1.76. You then can look this up in the table on the back of your books in Appendix 1, or a nice thing about Excel is that it's already built in. The normal distribution is NORMS DIST, normal statistical distribution. And then we would just plug in this z value we had. And you can see that if I were to format this in its final format, remember to always display percentages correctly. So we would change this to a percentage, 2 decimal places. And we would wind up with, there is a 71% chance, a 71.46% chance that we will have it done in 16 weeks. So that's better than the 50% chance that we have just not even looking at that, going with what we think it is. There's a 50% chance if you don't calculate these out, but if we were given 16 weeks, then we're 71% sure that we would be done. Like I said, you can also use this nice thing about using the normal statistical distribution in Excel is that you don't have to make modification for negative numbers. You can plug in a negative z. If you're using the table on the back of the book, you would have to look up that negative z as if it was a positive, and then whatever amount it told you in the table, subtract that from 1. And that would be then the probability that you would have the project done. I'm going to talk a little bit more about this calculation here because I want to make sure that we're clear on it. So I want to go back to that earlier situation that I talked about. Remember that we talked about if we were just to do our forward and backwards pass based on expected time, we would let you know that based on a normal distribution that this estimate of project completion is the halfway mark. We've achieved that mark based on how we calculated the expected time. But if we wanted to do a little bit more calculation, we could actually plug in 15 and figure out what that was. But we gave you the example of if we had an extra week. Let's do less than that. So let's say we want to know the probability that it would be done in 13 weeks, because there is a probability that it will be done. So once again, we would take then the 13 minus the 15 when we say it's going to be done. That's going to give us a negative number, of course, divided by our standard deviation. And remember, that is based on adding up the variances of the ones on the critical path. So we only are using the variance for those ones. I want to go over here and make sure that we're clear on that. So we've determined our critical path. Those are the ones without any slack time. We've added up those variances. And then to make sense of that, we take the square root of that number. So equals SQRT, parentheses, and then we plug in that value, close parentheses, and then that means that our one standard deviation is 1.76 weeks. That's how much it varies. And then we can use that to our advantage once again. So I said the example was we wanted to know what if they want to know the probability that we'll have it done 2 weeks early. 13 minus 15 divided by then this, that will give us our z-score. It'll be a -1. We then plug that one into or look it up on the table. You could look it up as if it was a positive and figure out what that number was and then subtract that amount from 1, and that would give you your probability. Or in Excel, it's easier just to use the normal NORMS distribution and then plug in the z value, in this case a -1. And we would say that once again we could format this one, format our cells so there's a percentage. And there is a 13% chance. So it's less than 50-50, and that should make sense because remember we told you that 15, so if we say our our project completion is 15, all we're saying is that we are 50% sure. We have reached the halfway mark. We've reached the majority. If you want to be assured that you can do it, then you need to go above the 15. As we talked about here, a week extra, so 16 weeks, we're 71% sure. But we also can calculate the probability below that, because there is a probability that you will get it done early based on the variability that we know. But it's only a 13%, 12.84% chance that we'll get it done in week 2 weeks earlier. So you can calculate lots of different numbers out there.